Rotational symmetry. A shape has rotational symmetry if it can be rotated about a point through an angle less than 360 degrees so that it maps onto itself. The less than 360 degrees is important here. Any shape can rotate around a point and land back on itself once it's gone all the way around. To have rotational symmetry, it has to be able to land on itself at an angle less than 360 degrees. The point which the object rotates is called the center of rotational symmetry. If a figure has more than one line of symmetry, then it will also have rotational symmetry. The center of rotational symmetry will be the point where the lines of symmetry meet. Now, earlier when we were doing line symmetry, we discussed the rhombus. So let's say that that's a rhombus. And we know that lines of symmetry were the diagonals. So where the diagonals meet, that would be the center. And then this shape would have rotational symmetry. The order of rotational symmetry is the number of times a figure maps onto itself during one complete turn about the center. So here we have an example with an isosceles triangle. We know that that only has one line of symmetry, and it doesn't exhibit rotational symmetry, because as I rotate, you see that the outline doesn't land on itself until it's gone a full rotation. So in that situation, we say that the object doesn't have rotational symmetry. The rotational symmetry order is actually 1, but we usually don't state that. It's 1 because it lands on itself once when going around 360. We normally just say that it doesn't have rotational symmetry because it has to go all the way around, which means it doesn't land on itself in an angle less than 360 degrees.